Now that you know the fundamentals of SCS curve number equation and methodology, we are ready to talk about components of this equation. Specifically, we're going to talk about initial abstraction, or I sub A, and capital S, or watershed storage. Before that, let me tell you that different components of this equation, rainfall, initial abstraction, and watershed storage, they are expressed in units of length, could be millimeters or inches, depending on which unit system you are using. Let's start with initial abstraction. Several studies show that initial abstraction, or I sub A, is a function of watershed storage. So alpha times watershed storage, or capital S. Now, the question is, how do we find the value of alpha? So traditionally, the value of 0.2 or 20% of water storage has been used for initial abstraction, right? This value has been used for rural areas and also for heavy rainfalls. There is a consensus around the value of alpha equals to 0.05. For the sake of this video, let's assume that the alpha value is equal to 0.2, meaning that I sub A is 20% of watershed storage. So I can write I sub A 0.2 times S. Now, if I take this equation, the equation for I sub A, and put it inside SCS curve number equation, I can have an equation that is a function of precipitation or rainfall and watershed storage. Let's write it down over here. Q, or surface runoff, it would be 0 if precipitation is less than or equal to I sub A, and we have the value of I sub A over here. So if precipitation is 0.2 is less than or equal to 0.2 times S, and then the other condition is when precipitation is greater than 0.2 S. All right. So assuming alpha equals 0.2, this is the SCS curve number equation. Now you're asking me that how are we going to find S, watershed storage? The answer to that is watershed storage is a very complicated value to find. In order to do that, we are going to use a unique number called curve number. Or CN for short. So the relationship between curve number, which is a unique number, and S, watershed storage, is like this. So you can find the value of S using this equation divided by curve number minus 10 if the units that you're using is inches. If you're using millimeters, this is the conversion factor. Curve number, again, if you're using millimeters. Watershed storage, or S, depends on the value of curve number. And the value of curve number, which is a unique number, depends on different characteristics of your watershed or the study area that you're considering. For example, land use and land cover changes the value of curve number. The soil distribution across your watersheds, across your study area, changes the value of curve number, and some other factors that can affect this curve number value. Now that you have a good understanding on how to calculate watershed storage, how to consider initial abstraction, in next video, we are going to talk about determination of the unique value of curve number for your study area.